The Giant Harbor Improvement Project is deepening New York and New Jersey's channels to 50 feet. To achieve this depth, millions of cubic yards of sand are dredged from the harbor each year. The standard procedure for removing the sediment is to dispose of it offshore. However, better use of the material might be made inside the harbor. Along the shoreline, inactive channels have formed repositories for fine silts and contaminants. Within these, the marine environment has degraded. If clean sand were to bury the contaminants, it would improve habitat and encourage the return of marine life. This task takes a bit of care to design properly. A successful design must be sensitive to the physics of the sediments. A good example is the channel south of the Military Ocean Terminal at Bayonne. The plan is to fill the channel from a depth of 30 feet to 15 feet without releasing black silt into the environment. At its surface, black silt is nearly liquid. The black silt is contaminated and should be confined under clean sand within the channel. One approach that's been considered at length but ultimately dismissed is to spread sand slowly and gradually. The load on the black silt would be distributed and a cap of sand would be produced. The black silt, however, consolidates only if it dewaters. If the water pressure in the silt builds too high, then mud diapirs could form, releasing black silt into the environment. The concern with this plan is that the sand cover is unstable. The possibility of an overturn of sand and release of black silt cannot be ruled out. Scientists and engineers on the project have produced a more stable and effective solution. The initial lifts of sand will mix with and dilute the black silt. The sand will produce a granular frame that will stabilize the black silt sand mixture. Each lane will be filled carefully with stationary dumps of limited size. The placement will skip every other lane going one way and then fill the gaps going back the other way. This sequence will allow a month for consolidation between each lift in each lane, confine the black silt laterally, and balance the stresses on the substrate. The second and third lifts will complete the mixing. Subsequent lifts will bury the mixture under clean sand. A large berm will confine all of the sediment within the channel. Mixing and dilution will bury the black silt. The plan meets the objective of a stable and clean sand bottom that's cost-effective. The sandy bottom will provide a habitat more favorable for the return of marine life.